What we're going to talk today about is kind of the day in the life of an ops engineer. And when we talk about it, let me just set the context up front a little bit here. This is a blend of technology as well as culture, as well as ways of working, because operations isn't just about tech. All of those pieces have to come together to have an effective operations strategy for your organization. And my name is Barb Malik, and this is Orion. We actually are both from AWS Managed Services, and what that is, and I'll go into it in greater detail, is we operate infrastructure on behalf of a number of enterprise customers. So it actually puts us in this really unique position of getting to see across a wide range of enterprise applications as well as organizations, and we can kind of evolve some patterns out as far as how we are operating infrastructure for them, and so we wanted to share some of those today.
So as was mentioned, I'm Orion. I'm a member of the cloud security team for AMS, and I want to apologize to everybody up front. You can hear that I have a little bit of a frog in my throat, and if I assault you with a cough or a hack, that's it's par for the course. I apologize in advance.
So what we're going to actually go through, and when we were putting this session together, we were trying to figure out, okay, how do you put a day in the life of an operations person into a 60-minute session and have it meaningful? So what we actually talked about is focusing on kind of scenarios, stories that we thought would have the most benefit and that we saw across the applications that we were dealing with.
Yeah, so we picked a couple of stories that we thought were really evocative and did a good job of showing what it is in our day-to-day actual lives of supporting our customers. So all of the stories that we're going to talk to you about today are real stories. They're real things that we've done or are doing on an ongoing basis. Some of them aren't quite in a day. A couple of them span a few months. But they're also the kinds of stories that we tell internally. It was a big way of how we picked this. When we get somebody joining the team and we want to tell them this is what we do, this is how we do it, this is the way that we approach our problem solving, to let them know what cloud operations means for us, these are the stories that we picked. And we've got some nice and pretty descriptions of what those stories are. In reality, the first one that you see there, our interaction with CloudWatch Logs Insights, is really like the thing that saves your bacon when somebody asks for an RCA, or a root cause analysis. It's a really powerful tool for going into that, and we're going to go through a demonstration of trying to answer a pretty hard problem through CloudWatch Logs Insights. The next one is the Ballad of the Bakery, which we're going through and pulling in customer applications that come in from on-premises, and we talk a lot about the maturation lifecycle. Not everything comes in perfectly cloud ready, very well spun up so that you can lose any instance and nothing will ever go wrong. So we talk through the lifecycle of something becoming more mature, more operationally ready, and more ready for the cloud, and how we help our customers through that. And obviously we can't talk about ops unless we have something on disaster recovery. And so the question that we have there is, what do you do when something goes wrong? And more poignantly, how do you make sure that you're ready for that before it happens? So we talk a lot about the preparation for how we get our customers into a disaster recoverable place.
Exactly. And then we'll actually round up with just touch on a little bit kind of the characteristics of cloud operations people. We're watching it change a little. We see even within how we're operating on a day-to-day basis, the way the skills are maturing and evolving and how they're branching out from how it used to be, where it was a little bit more siloed. And a lot of you might see that in your own organizations as well. So we wanted to hit on that one a little bit. So real briefly, just for those who may not know what AWS Managed Services are, I'm actually just going to hit it. Like I said, what we actually do is we take a curated set of AWS services. So we actually use our own services to operate infrastructure on behalf of our enterprise customers. We actually have a secure and compliant landing zone that's built out. Since we're operating it, we're pretty prescriptive about it. I usually like to flip that around. We do really well with you build it, you run it. I think the inverse is also true. If you're going to run it, you get to build it as well. So we take that into account. we leverage a ton of automation. And so a lot of the scenarios we're going to go through, we'll talk through how you would do the normal scenarios where they would be operated like auto remediation through alerts. But we're going to actually hit on the ones when you don't have something for that. And then we actually have AWS Cloud experts as well. So people like Orion and myself, we actually work with customers to help them through that. So that's kind of where AWS Managed Services comes into play. And like I said, that's what helps us to be able to kind of have a unique vantage point in seeing operations at scale with AWS. So that was a lot of words about what our services are, or what the actual service is, but here are the capabilities that we provide for customers, and these are probably a little bit more in tune with what you see when it comes to operational aspects. So we do provisioning and onboarding, really heavy with the CloudFormation templates. That's actually what we use. Again, we use all our services, security and compliance. So we use things like Guard Duty and Macy to go through that, monitoring and alerting, and we're going to dive a little bit deeper into that one, as well as we try to drive costs down. Our whole thing is to actually, from an ops standpoint, provide insights back to the organization so they can continue to drive some of those costs down. Patch and backup, we leverage SSM to be able to do that, as well as we have a change management system so that we can provide evidence of controls to customers. So I've now done the obligatory, that's what our service is, but now let's actually start getting into, okay, what is operations and what do we really do when we're operating that infrastructure?
Yeah, and so the answers to that really come down to who you ask. And if you talk to my friends, they were pretty certain that given the amount of automation that we champion, we just sit around and play video games all day because we've clearly automated our jobs away. Now, if you were to ask my folks, they would tell you that I'm saving the internet from constant outages and incidents, diffusing bombs left and right. And that's not entirely untrue, but we try to do it in a calm and coordinated manner, make sure that we do everything in sequence. And so if you were to ask the customer, they would say that I'm sitting idly by while a fire rages. And we're getting to it. I promise it's being put out. We're solving the root cause. And as the result, my vice president is pretty sure that I've never listened to anything he's ever said. I do, I just haven't had the time to do anything about it. And that's reinforced by the fact that my manager sees me almost like this every day. This is a little bit off. I don't wear shoes in the office.
Valid point, he does not have shoes on here either.
I know, I managed to come up here without shoes too. And then there's the reality of what we're actually doing. And this is a really important point because the joke of on-prem IT is, yeah, you turn it off and on again, usually it comes up right. You're using really legacy solutions to solve your problems. And one of the lessons that we've learned time and time and time again in cloud operations is that the solutions we're implementing actually aren't very different than what you're implementing on-prem. Turning it off and on again actually solves a lot of problems. There are many things that we do by turning it off and on again, or redeploying it if we have something safe enough that we can redeploy it. Because there's been some drift, there's been something that happened in the running instance, and we need to clear that out and get it fresh. One of the themes that you'll see come up a couple of times here in the stories that we're going to tell you is that while we're coming at our problems with cloud-native solutions, things are a lot faster, cleaner, and cheaper for us to do, and that allows us to iterate and move faster on them. We're fundamentally implementing the same root solutions, just in a cloud-native way.
Yeah, I think that part's really key as we go through this. A lot of the people that we talk through, it's like, hey, we're going to the cloud, so I don't have to do that patching and backup stuff anymore. Yeah, you kind of still have to do those things. Not all applications are cloud native and are all immutable and can do that. So you have to have good strategies around that, and we see it constantly with the workloads that we're actually operating.
Yeah. Yeah, so
I was going to say, our next one, so I talked about the fact that we have automation, and we do have automation from our side, and we have all of those things really well, but there's always those scenarios that come up that you can't account for. We continue to learn and try to bake that in, but there's always that question that you get asked, and so we figured if we run into that, you guys probably will also, so Orion, maybe
Yeah.
take through the scenario we were going with this.
Yeah, so I mean, one of the questions I'm sure you've all gotten is, how many times did this happen? This being something was gone wrong, something has been errant. How can you be sure that there's no impact? And how can we be sure this isn't going to happen again? These are really common root cause analysis questions. They're things that we have to answer on a regular basis, and they can be really challenging. So we're going to talk through a scenario here where we had an SSH key, and we needed to find out if that key had ever been used to authenticate to anything anywhere in our environment. It's kind of it's a funky question. It's a very simple one at its core, but it's kind of hard to answer. We've got a lot of logs out there, and we're essentially trying to audit all of them together. And so we're going to talk through our strategies of how we get to do that. The system that we're using to do this is CloudWatch Logs Insights. It's fundamentally the platform of CloudWatch Logs operates on the basis of log streaming. And then once it's been streamed into CloudWatch Logs, it allows you to search through those logs across large environments. And then we can make assertions like whether or not improper access has occurred in relation to a single key.
Again, similar to what you're doing today, you have to have some sort of log aggregation strategy, regardless of where things are running. You're aggregating the logs. A lot of times what we're seeing from an organizational standpoint is people may have things like, hey, the logging group, and you have to request logs from them. And so what we're trying to do is you still have to have that capability to be able to have access to those logs. You still have to ensure that you're actually logging everything. But what we're trying to do is come up with more seamless ways to be able to get that information more readily, more quickly. And so that's kind of, and I believe we're going to start off kind of simple, and we were doing this when we were talking about it, and we find this with customers. It's like, hey, the first couple customers that came on that we were actually operating on their behalf, it's one or two workloads, you're doing something. You can use different approaches, but when you start getting to scale, then that's when our automation is coming into play, as well as coming up with the insights. And don't choke in.
Yeah, and don't choke while you're on stage. Literally, the metaphor is fine. So yeah, when you want to approach that, you're going to need to come up with a little bit of a strategy on how you want to manage this. And there's some technical requirements of our implementations that I'm going to go through here for you and explain to you how we handle this. A little bit of recommendations and some option points if you're trying to do something similar in your environments, because these are examples. They're not the only way to solve this problem. So let's say that I've got an instance. It's standard Linux. This works the same for Windows, except that you're going to stream the Windows event logs. You're streaming a number of logs that you care about off of this instance, and you want to get them into CloudWatch Logs. In order to do that, the way that this operates is you get the CloudWatch Logs agent, which is going to be a daemon that runs on your host, and you configure it through its configuration file to read a couple of logs and stream them to CloudWatch Logs. And in order to do that, it needs to be able to pull credentials that are able to make those API calls, because those are fundamentally AWS API calls that need proper authentication on them. The way that we do that is pretty standard. Throw an instance profile on it. Once the instance profile is there, the credentials necessary to make the API calls to put those logs up are going to be available in the metadata service. It's going to need create log group, create log stream, and put log events in order to do this. I want to talk through a little bit of the difference between those API calls and why each one is necessary. So when you create a log group, you're putting together like not to reuse a word because S3 uses this, but a bucket of different logs and log streams that you're going to have available and grouped together. What we do is we name that bucket, that log group, after the instance. We take the instance ID and we throw it there. That way, when that instance goes away, maybe it's part of an auto-scaling group and it's gets torn down sometime. Maybe it's part of a CloudFormation template and you update it and it gets recycled and rebuilt. Great, but you've still got those logs. You're never going to have the question of, well, did anything ever happen, even though that instance doesn't exist anymore? And so we've got that canonical record there in the log group. Now, once that log group is created as part of your boot scripts, it's going to go and start sending each of the logs that you wanted into its own log stream under that log group. And so the way that we structure this is literally the canonical path. We just say if it's var log messages, name the log stream var log messages. It's very straightforward, makes it really easy for you to consume, really easy for your operators to intuit this is the way this is working. Because you're going to pull in a lot of people that know exactly how to find something on an instance. And if you want to spend a lot of time training them on how to deal with your particular logging solution, you could do that. But as much as we can keep, apples to apples, let's keep all the names the same. The one thing, oh wait, no, one more.
See, I didn't really want him to touch the remote because he's been coughing. So.
Yeah, I know. No, only one of us at a time. Yeah, and the other thing you want to do here is get all this configured as part of your boot scripts. And there's a couple ways to go about that, and we'll touch on them a little bit later. The way that we manage that is that we give instructions to the instance as part of the instance metadata on launch for it to run. There's a lot of ways for us to handle this, and I'll again cover each one of those later. But that's the way that we handle it.
Right.
Now So when I put this slide up initially, it didn't look all nice and organized. It was kind of the point. Your instances don't look like this. They don't look like a standard, nice grid with a little offset to make it look pretty. They're scattered between subnets and VPCs. They're across. They're everywhere except for under somebody's desk, because you can't really do that in AWS until you get some outposts going. And so the real issue that you're always running into is like, where do I find all of these resources? Where do I get all of these resources together and make sure that I have all of it? And that's why the other side of it is actually supposed to look orderly, because that's your CloudWatch Logs insights, or your CloudWatch Logs. They're going to be well organized, really easy to look through. All the data is going to be right there. And the point that we wanted to make here is that the solution that we presented in the previous slide is scalable. It's, just go ahead and keep on churning this out. This is something that you can deploy 1,000 of, and you're not going to have a problem. And now we get to the actual problem that we want to solve. So I've got 1,000 hosts across different subnets, different domains, all over the place. And I need to know, did anybody ever use an SSH key to authenticate to something? And so what you're looking at here is the CloudWatch Logs Insights console. Obviously you can do all of this through the CLI, and you will end up doing that, but it's really easy to demonstrate what we're seeing here from here. We're making a query against a bunch of log groups. And you can specify as many as you want, however many you want, wherever you want. And we're pulling a couple of fields. And what that's doing is essentially, you're pulling that data and you're assigning it to variables. So we've got a timestamp, a message, and a log stream. These are natively defined by CloudWatch Logs when you make these queries. And we want to filter the log stream to just var log secure. And that's really useful because it means that we're not going to churn over a bunch of extra data, because I don't care about what's in var log messages. I don't care about what's in the app log that I'm streaming. But just var log secure. I'm just looking for authentications from a single SSH key. And then I want to say, all right, filter the message like public key. And this is a standard. You'll notice this looks very SQL-like. It's kind of the structure that they're going for. Filter the message like public key. And so it says it's got to have public key somewhere in it. It'll drop anything that doesn't have that string in it. Again, this speeds up your query. This is a way for you to minimize the amount of analysis that you want to do to get it to stop parsing through data so it can find the real answer for you faster. And then you want to say parse the message, and then we've got a bunch of asterisks. What these are doing is these are really, think of them like regular expression capture statements. So they're going to get assigned to variables that we're defining later. So we're saying star public key, and that star is something I'm defining as A. I'm defining it as A because I don't care about it. I'm not actually looking at that piece of data later. This is just to get rid of part of the structure. Public key for star, and then I care about this one. This is a user. Port, okay, and then that's the source. I care about that one too. B, again, additional data in the log. RSA, and then this is the one that I'm actually querying on. The one that I'm really filtering for is the SHA-SUM. I want that SHA-SUM because that's the reference to the SSH key that I have. If you authenticated to a host, the host hashed your key. That's the only way that you actually manage to get in. That's how it works. So that SHA-SUM is going to be there. This is allowing me to answer the question canonically and authoritatively, has this ever been used to authenticate to any host? And the answer, as you can see from the bottom there, is yes. I've got a bunch of authentications. That key has been used all over the place. So this is a positive match. And what you can do with this is you can actually expand this a little bit further. You can go ahead and say, I want counts. I want the number of them, I can start to make references to the timestamps, start to build a date range out of this. You can also say, I want to know all the sources. I want to know where these keys are coming from, and filter that by uniques. Again, SQL style interface, it's pretty easy to use. I don't write it very fast. And so at this point, we're still building out and continually building out our own internal just categorization of all of these queries. When we have to solve a problem, we come back and somebody pulls out of our repo. This is my query for finding out if somebody has ever used an SSH key. This is how I solve that problem. We've got dozens of those.
I think actually one of the points that's in there is we actually have a whole repo of ops scripts that are run as well, or queries that are out there. Again, we're starting to treat ops similar to it's code. It's ops as code. We version it. Everybody doesn't have their own version of these. We actually have a repo that those are out there. You version them as we find different things that come up, so we get more efficient as far as when our operators are actually going in and looking at the infrastructure.
Yeah, and it's a really good point. So in addition to the fact that we're treating this, operations as code, we're making sure that we're formalizing, I have a good solution to this problem. Let me not have the guy next to me spend, 2 hours developing his own solution to this problem. Let's not waste our time on that. Let's also double down on it and say, and instead they can spend 2 hours improving on mine. So there's a more efficient way to write this. There's actually many more efficient ways to write this. If you want to minimize the runtime of this query, if you want to minimize the cost of this query, you can write this to filter earlier and filter better. And so you're going to ultimately parse less data and going to make everything faster and cheaper and easier. And so when the next person looks at this and they say, wow, Orion, you could have done better, and they go and take their whack at it, they're going to store that, they're going to throw that into our repository, and we're going to version it. We store this as code. We've got our own Git repo. We're handling all of this internally. Because treating operations as operations and not operations as DevOps, which it really is going to result in the next person over developing another solution, maybe not better this time, maybe worse.
Saw a few people that are actually taking pictures of it. The slides actually will be available after, and so you can actually get that, since it's kind of hard to see, as well as the reference links to everything that we just walked through here. So when you go back, you can take it and set it up, and we would encourage you to actually experiment with that in your environment, see the different questions you get asked, and start building out your own repos.
Yeah, these are hyperlinks, so pictures won't help you.
Yeah, and I think you actually covered most of these. But some of it is also around governance, if you will. So kind of a bad word there, but it's how do we ensure we're aggregating those logs, and then how do we control access to those logs? Because a lot of times organizations will segregate out the logging team, and you have to actually request from there. So I don't know, as far as maybe quickly, how we actually deal with this.
Yeah, so there's a couple of different questions to that, and I want to touch on each of them. One of them is, how do we make sure that we have the logs? How are we making sure that things are getting posted? The control that we implement for that is pretty straightforward. It's since we use CloudFormation to launch everything that we run, we just have gates on CloudFormation signals that are sent by our boot scripts. And those signals won't be sent until after the logs successfully create their streams. So you automatically know that you're going to be getting logs out of any given host before that host will be considered healthy by our environment. There's a lot of other ways to solve that problem, though. This is not the only way. You can do it as part of your CloudFormation boot scripts. You can run it as instance metadata. You can build it into your AMIs. You can send SSM run commands or SSM associations for all of your hosts to make sure that this is going to run. There's a lot of ways to solve this problem. You're going to find the one that works best for you.
I was going to say, I was just kind of moving to our next scenario. Hey, we're getting close to the holidays, so we said, hey, got to have some baking in here, but it's the ops version of baking. It's our ballad of the bakery. Usually, and we did this a little bit when we started, have to admit, it was, hey, so-and-so, how do you do this? And a lot of it was handed down. We did figure out that really, really quick that didn't scale. And so what we actually did is have to actually build out a bakery. And maybe Orion, if you kind of want to walk through what we did. And there's different approaches, and you kind of iterate on it within your organization. So, you know, we didn't start off at the end state. You had to iterate through it, and we've figured it out now. We're pretty good at it. But
Yeah, yeah. I mean, we've gotten to the place where we kind of know what's best. We have good answers to these problems, but every customer who comes in is going to be their own, you know, their own snowflake, their own custom problem set, and so we're going to have to go through that journey to maturity with them each and every time. And sometimes things come in, and you know. And everybody looks at it and says, you know, we're going to work on modernizing that application a little bit. It's not going to happen this week. We're going to get to it when we get to it.
we see, I was just, where these really come up a lot, and we kind of alluded to it in the beginning, even though you're in the cloud, you still have to patch. And so the bakery comes in really handy when you're starting to deal with not only operational, like OS level patches, but security patches. And how do your applications respond in those scenarios?
Yeah.
So maybe if you can kind of walk us through the most simplistic way to do it, and then we'll kind of take you through the lessons we've learned going through that and some of the gotchas. That doesn't mean you can jump right to the end. I think you may try some of them as well.
Yeah. Yeah, and this is really the simplest implementation we have. This is the barest bones way you can move something into the cloud. You're going to start out with an application running on some server. You're going to bake that into, you know, a hypervisor image or something like that. You're going to transfer that into an AMI, and you're going to boot it into an EC2 instance. Like, congratulations, you have your application running in the cloud. And every single one of our customers has done this at least once. You know, they may not do this, they may be way beyond this before anybody ever cuts anything over it live, but we do this to say, like, all right, this is the minimum, let's iterate. Let's keep on moving forward and keep on maturing.
Right. So then we kind of evolve to the next stage here, and this is, and I think some of it, and what we've experienced is, as customers are trying to balance that, hey, the time that my application may not be available with the amount of time that it takes to actually patch, like what other options do we have in there? And you may use a variety of them.
Yeah, and so we've seen this a couple of times. It's been a model that we've used before, where we essentially say, all right, let's do that first bit. We get an AMI, we want to boot it, but we've got a couple of operational readiness requirements that we want to fold in there. So we want to get some level of you know, ability to recover if an instance fails. You know, tear it down, build me another one. We want to have a little bit of the ability to scale in, scale out, like autoscaling does if the load gets high. And these are really valuable services that autoscaling groups can provide to you. But you've got a problem, which is that you have an AMI, and AMIs are immutable. You know, when you make an AMI, that AMI will never change. And as that AMI fails to change, the environment does not. You know, you've got patches coming out, and they continue to come out. You've got critical vulnerabilities that pile up and pile up and pile up. And so you can say, as one solution does, all right, let's just have it run updates during its boot time. Let's just say when it starts up, while it's, you know, before it comes healthy, it goes and runs a bunch of updates, and then we cut it over to green, which works, but it is going to present you with an ever-growing update period. It's going to get longer and longer and longer, and at a certain point, it's actually going to flip over the health check period for your autoscaling group. And the autoscaling group is going to conclude that this boot failed. It never successfully came up healthy, and I'm going to tear it down and build another one, which also won't boot. So you've got yourself into a situation where I need to update has turned into a full-scale application outage, and that's a real problem. So when we get an incident, as we have had these incidents of something has gone down, it's not coming up, and we need to go and pull it out of the auto-scaling group and put it on standby and manually patch it, and, you know, burn a lot of ops hours in trying to solve this problem to make sure that the auto-scaling group won't tear it down before it's ready and can throw it back in. We then realize we need to modernize this application a little bit more. We need to take it to the third level of maturity.
Before we actually go to the third level, like these go really smooth and they look great on slides. Yeah. However, we also saw not all application stacks are created equal. So what, and maybe just sharing a little bit, what are some of the problems that we've run into when it comes into this with the leveraging the auto-scaling groups.
Yeah, so there's a couple of issues that you can run into, and a lot of these come down to just architectural mismatches between the auto-scaling group implementation and the application itself. So sometimes it's the right fit, and sometimes it's not the right fit. Sometimes you've got an application that requires some amount of host registration. It's connecting to some other service somewhere else, and that service needs to know source IP addresses. That service needs to know the host name of those instances. Maybe your application doesn't do well with dynamic host names, and you really need hard-coded host names, but then you're running into conflicts because something's getting torn down. Now you've got two instances in the same domain with the same host name, and things are bad even though one of them has been terminated. So there's a lot of situations where you can run into issues here. Another one that really plagues operations is when you're dealing with auto-scaling groups, you just have to walk on eggshells. Any time you're in an auto-scaling group, you want to think for a minute, all right, what do my health checks look like? How do they operate? What am I doing? Does that pose a risk of me failing health checks for long enough that I'm going to get terminated out? Because then I'm going to lose all of this progress. And so you spend a lot of time making sure, again, throw something into standby, make sure that you never accidentally tear it out. And then once you've gotten it there, then you can do the remediations you want on it. But it's a little bit harder of an environment to operate on. It's designed for production-ready applications, and it does a really good job of those. If you're not there, you want to spend some time modernizing.
Which is kind of how we got to where we are, and again, the theme of operations as code and switching this a little bit, changing the ways that we're working. So you actually start, well, spoiler alert, we start building an actual pipeline. So.
Yeah. And so this is where we get into the bakery. The verb that we use for preparing an AMI is baking an AMI. And this is what we would call a bakery here. And so we've got the same ingress point for the applications coming in from on-prem. We port it in. We've got an AMI on it. That's great. But we've got another ingress point for new code that we need to handle. And that's updates that are coming in. Now, we don't apply those directly to the instance that's running in prod, because that's crazy. Obviously, we apply them to a patching instance that we spin up specifically for this. And so we take that AMI that we have, and every day, every week, every month, every time a critical update comes out, whatever your tolerance is, we go up and spin up another instance for it, out of it, and then we apply patches, snapshot, bake an AMI, and then we replace it in the auto-scaling group, and we trigger replacement on all of the instances there. And that really solves the growing gap between your AMI and your live patch situation. At that point, you've got your live patches moving out, but your AMI keeps on advancing, keeps on moving forward. And to what you said, there's a term that we use to describe the automatic application of code into a running production environment. It's called a CI/CD pipeline. Normally, when you guys think about your CI/CD pipelines, this is something that your DevOps team is building in order to facilitate faster iteration between your development teams. In my experience, it's life and death for operations too. We need a CI/CD pipeline on our patches. And so when we go and need to apply all of these patches into production, it sounds like we probably need to run all of our tests again, because maybe they broke something. It sounds like we don't want to burn a lot of operations hours, like moving things into standby and managing a bunch of manual infrastructure operations. We want to build a full CI/CD pipeline. And so the lesson here is that even though this isn't code that your company is writing, this is the code that Red Hat or the Linux Foundation or Microsoft is writing, you're pulling that in. And just like a dependency from another team internally, this is a dependency for every application you've ever run, is the infrastructure code. And so, yeah, build a pipeline around it.
Again, you're seeing the constant theme here of changing kind of the ways we're working, and we're finding that within our operations team constantly, where we're continuing to evolve. So we now have two different scenarios that we've gone through here, where we have code that we're versioning and managing in pipelines and leveraging the same tools in a lot of cases that our developers are leveraging as well. Kind of just recap all of this. The last piece in here, so we talked about the CI/CD pipeline. That's what you're actually doing, booting. as well. The last part of that we didn't hit on is a little bit about watching the sprawl that you can get with all those snapshots that are taking place. Sometimes you might want to actually put some policies in place as well. We do that as far as based off of what our customers are telling us from a retention standpoint. Don't leave them hanging out there. Continue to clean those up.
And where in the lifecycle of an application would you say that you want to start approaching your lifecycle policy for this?
Yeah, generally, as far as like when we're working with different customers, what we're doing, and this is kind of that shift left on security and operations, we may not do it up front, but we definitely want to influence it at the time when they're coming over. We really want to understand if you have any characteristics of that application that are going to have to hang around, whether it's for operational needs or compliance.
Yeah.
We talked a little bit, like we said, there's no good ops session that you can have that doesn't actually address some sort of disaster recovery, and it's probably better described as disaster recovery planning or scenarios, and there's a lot of different ways that you could approach it. We could talk about it in terms of applications, but what we actually decided to say was, hey, let's actually take on the challenge of if you lose an entire region, and this is actually an exercise we go through with our customers a lot, an entire region goes down. So again, on our shifting left here, we actually work on that up front. We start to understand what your recovery point objectives are and recovery time objectives. And so with that, we'll help go through, and we're going to go through the tech part of how we actually do this. But you have to understand what you're working with and what those parameters are, because not all applications are equal, and there are dependencies that are in there. So, as we'll share the good, bad, the ugly, how we iterated through that and how we got better as we're doing it. And we didn't get it right the first time, but we've gotten better now in being able to ask the question, so we'll share that with you.
Which is a really important thing. You didn't think you were going to get it right the first time.
No, we actually planned for, we knew it, and we set the expectation up front to say, we're going to go through this the first time. I can guarantee you that, we'll be able to recover it, but it won't be in an ideal state. Similar to how you go through anything, we want to inspect and adapt as we're going through it. And so we actually iterate through DR scenarios with our customers multiple times a month, or it's really to the extent that their resources can allow.
You may actually notice that as a little bit of a theme that we've seen in the other scenarios as well, is at no point in any of these processes do we say, like, we start out with things that are perfect, everything's running great, we have everything in place. We say, okay, we get something that's good enough for today. And then we acknowledge that as a gap that we're going to need to move forward on. And this is exactly the same thing. We don't start out looking for perfect because, the perfect is the enemy of the good. You got to start somewhere and start iterating on it.
Exactly. And so the challenge that was put back to us is restoring into all the applications that are running in this region. And I think at the time there were like 200 applications that were running in a particular account, and have it all restored within 12 hours. And it was like, oh, okay, well, no problem. Not typically how we have done it in the past.
Yeah, how does that map to on-prem timelines? Like, what would that look like if somebody said that to you?
So I had to explain this a little bit to Orion when we got the challenge. It's like, okay, this is a little bit different. When I used to do that, we actually had to travel someplace, and we actually took run books with us, and you had to coordinate it, and there was travel that was involved, and it was a pain. And oh, by the way, we didn't actually recover all the applications. We kind of knew which applications we were going to have to recover, and then we provided that evidence back to the auditors.
Like just a couple of critical ones.
Yeah. Just a few, because you just couldn't do it at that scale. It was expensive to do. And so for me, at least, this was interesting to go through and start planning this out from the beginning. It was like, again, how do we start thinking about how we want to do DR? And in most cases, what we're actually advising, and so from an operations standpoint, anytime you guys can lean in on your teams that are actually doing migrations or building net new, get in front with them and start talking about DR so that they can build it in there, because it's painful if you're the one that has to recover it after and you didn't think about it up front. It takes way longer. Yeah. And we'll kind of go through maybe some of the steps that we went through as well. So maybe you want to start walking through.
Yeah, so I can walk us through a little bit of the architecture here. And again, this architecture was significantly influenced by the fact that the environment was set up with disaster recovery in mind. Not all the pieces were in all of the right places, until we'd gone through it a couple of times, but the core design was there, and that was what we ended up using. So you can see in our production account in US East 1, this is actually our live environment. This is prod. This is what's going on. And then on a regular basis, we've got like 2 fundamental resources there. We've got application instances that don't have highly sensitive live data on them. They can get snapshots that need to be roughly up to date, but they don't need to be within an hour. And so what we do is we set up a Lambda function that's triggered by a cron job that goes and takes snapshots of each instance, and then it copies those snapshots into US East 2, and then copies those snapshots or shares those snapshots with a recovery account. And so that gets those into place so that we're ready for disaster recovery. The other side of that is that we have EC2 database instances. These are actually not RDS instances. These are SQL databases that are running on EC2 for various application reasons. And so we do a live replication actually into the target disaster recovery account. And that's running all the time. Now, you can think about the reason that we do that is because there's some of that data where we need to have it up to the last minute. It's not acceptable for us to drop transactions. It's not acceptable for us to drop any calls. And so we need to make sure that we actually get live data out of that. Now, this is more expensive because you have to run those instances on the recipient account. The snapshot sharing, on the other hand, is comparatively very cheap. It's a snapshot. Theoretically, it's an S3 object. It's not that big of a deal.
I was going to say, one of the things to point out, and I know, we actually said use 2 separate accounts, and you can use the same account for it, but from our standpoint, and one of the things that just working with different customers, you don't really want to get into a disaster scenario and find out that, oh, maybe I'm out of IP space in my account and now I've got to spin up stuff. Or, oh, I'm at my limits as far as what I've used. I'm in the middle of my DR and I'm trying to request actually limit increase. So it's just for kind of purity of the account, if you will. It's instantiate an account that is dedicated for DR. That's its sole purpose. You don't have to worry about drift actually coming into that account.
Yeah, I mean, if you're an operations team that's dealt with AWS accounts, tell me if you've ever found a resource in a region that you didn't think you operated in. Yeah, that's pretty much everybody. So, if you're in an account that you're not keeping for a specific purpose, it's going to get used for another purpose. You're going to just find out about it later, and you don't want to be caught off guard on that. When you go into your disaster recovery mode, you want something clean, you want no surprises, because you're operating on tight timelines.
Right. And so one of the things that you'll notice in this one, that the center section on the slide there, the simulated prod environment, we were doing this without taking the applications down. So in this particular case, there was really more work in simulating it than if there was an actual disaster recovery, the event that we had to go through. Because what we wanted to do was ensure we didn't actually mess up any of the data that was going across. So we kept that live sync going. So we had this added step in the center where we actually would take a snapshot of the actual database that was in that DR account, and then we would create those databases again, where in a real life scenario, you would have just flipped it over and gone with that as the database.
Because you wouldn't have had any additional data because the prod would have been down.
It would have been down, yes. It would have already been down. And then again, back on code, what we actually were doing is we were doing the provisioning of all of the infrastructure with CFN. We were treating that as, that's okay. We were treating that actually as code and keeping that in place. So we had all of those CFN templates available. We made sure we had the copies of the snapshots. So then we actually decided, okay, this is how it's going to flow. We're going to go through this exercise. And then we would actually restore the instances and then just repoint to those databases that were in there. So it looks really good as far as on this side, and I will say it works as far as in being able to attach it. Some of the things that we learned in going through these, the first time we actually went through this, we uncovered the fact that it was like, this is great, we have all these CFN templates, we have all these snapshots. We don't know which one goes with which at this point because customer in that particular case didn't have a very robust operational tagging strategy. So it required us then to go through another iteration of it. So we went through the second time. We said, you know what, we now have things tagged. We know what goes with what. we're going to create the run books, and we're going to test those. But that was really labor intensive to be able to do that. So what we actually did is on the third try, well, the second try we went through and we tested them like, okay, cool, this works. We had all the people that were executing those run books. We got everything restored. I think by the second time it was like we did it in 12 hours. It was like, cool, we met it. But then we have a lot of really competitive people. And so it's like, we can do better than that. Like, I don't want to do this again. It was like, while we met the goal, I just don't want to do this. So we're going to automate it.
Nobody likes 12-hour shifts
Right,
of,
yeah,
like massive
it was just
calls.
one of those.
Yeah.
So what we did is we actually automated all of those. And on the third time when we went through, we were actually able to restore all of the applications and getting them to a running state within 3 hours and be able to have the evidence to show that. So if you think about that from both an operations standpoint, you've got the automation in place so you can work on other things and not have to sit here and manually go through it. From a business standpoint, it's an incredible value that you're actually providing back to them.
And let's hammer on a little bit of like what those phases look like. So we show up with phase 1 there. We're going to try this disaster recovery. We don't think we're going to meet our timelines. We want to see what's not going to work. How was our plan wrong? And then we figure out like the right things to do because we do everything, and eventually like we do get the disaster recovered. So, congratulations, we definitely have executed the correct steps. And we get to our second run through, and that time we're verifying that our conclusions from round 1 were correct, because we were making changes in a crisis. We were figuring out how to do it while we were doing it. And we don't want to do that when we're going to go to phase 3, which is we want to automate it.
Right.
So we want to make sure in phase 2 that we have the correct set of steps, because you can't automate something that you don't understand. You have to go through it and figure out where the bugs are in the process before you can go through it and figure out where the bugs are in the program. And so when you get to phase 3, that's where we start to move a lot faster,
Right.
get a lot better conclusions, is once we start to write all of that process into code.
And I was going to say, and those are stored. So from a customer standpoint, they've actually built those into their processes on their side. So they're thinking about the operational aspect of it, and they're versioning those, and they are keeping those in their code repos as well. So we can actually leverage it from that standpoint.
And again, this is operations as code. This is,
Right.
This is exactly what you would expect from a DevOps team, except it's not coming from the development side of things. It's coming from the operations side of things.
Yeah. So I think we've done the planning part is key. The other part is actually running through those game days. That is a great way to, one, learn where you actually have the gaps, as well as get to the point where it becomes very routine and you have those automated and you have all of those scripts. So we've talked about a number of things as far as I think through all of the examples, where we start out kind of with this manual approach and then we move through it and then we're actually getting to the point where we're automating it. Yeah,
now people. So last time we went through this, we had a lot of questions on, hey, who are you? What are the people that you're hiring for? What are you training for? How do you develop a good operations team? It's a really challenging problem, and a lot of people are facing it, and a lot of people are finding their own solutions to it. And so again, we're not here to tell you what the right answer is. We're going to tell you what we're doing in order to build a successful cloud operations team, and talk a little bit about the engineers, the people, what we're doing.
Absolutely. So these were some of the things that we got hit on in those questions all the time. It's, do you go deep with skills, or are you a generalist? Do you actually how do you actually grow people out here? It's like I have an operations team, and now I'm actually moving into talking about all these things with dev from that standpoint. So how do you actually get to that point? And yeah. So we'll go to the next slide, and this is also the, you build it, you run it. I told Orion, you make the slide, you have to talk to it.
Yeah,
and you'll see why here
this
in a
worked
minute.
better on a whiteboard at
Yeah.
one point, and it didn't translate well into slides. But the point that we were making here is that when you look at your traditional model for what your operations team is looking for, they're going to have a lot of silos. They're going to have different people. They're specialists in different parts of your organizational technical responsibilities. You've got your network team. Your network team is killer. They know like every layer of the OSI model. They know alternate layers, like alternate models for networking. They're going to talk to you about how TCP/IP is just one option, really. And they know their way through BGP. They know everything that you're going to see in router land. And then your systems people have no idea what BGP is. They know what IP addresses are. They may or may not know what a subnet mask is, but like, if you know what a kernel is, odds are really low that you're also somebody who can configure a router. That exists, but it's just not what you're going to see coming out of the gate. And similarly, you're going to see database specialists that can build an optimized schema and maximize transactions per second, really have the right conversations with you about where to cache and how. But all of these are going to be silos. They're going to be individuals that know the minimum of their adjacent fields to get their job done, and that's not going to be very much. They're only going to need to know a little bit. And that's not been our experience in cloud operations in AMS or in AWS. The other side of this is showing kind of like where we end up seeing people start out. Like most people show up with a good amount of networking systems knowledge. And there's a couple of reasons for that. One of them is that they're where a lot of the fundamentals take place. The low level on databases is fundamentally systems information, and then you get into the really fun, cool math. But you're like still going to understand how file systems operate. And networking is really indispensable in AWS. Much more than in on-prem. It's very hard to do things in AWS for very long without picking up a little bit more networking than you might have known before. You're going to find out a lot about how networks work just because AWS is built with networks in mind. It's really core to its function. But once those engineers land in our team, they start working, they start looking at their problem sets, they start expanding into other fields. And this has been our experience, is they start out with some like origin point on the graph of all the skills, and they just expand out. So you may have noticed that my title this year was not operations engineer, it's a security engineer, and that's because I was part of our operations team, and I started branching out into our security, and I started answering a lot of the security problems that we had. I started answering a lot of the security questions that my colleagues had. And at a certain point, I was operating as a security engineer, and that's what we've done. And this is how we develop our team internally, is to recognize that we're all going to come at this from a generalist perspective. Everybody's going to know a little bit of everything, and you're going to see people start to branch out. And so then you get to what a cloud operations engineer looks like these days. It used to be traditional silos of somebody who knows everything about anything. And these days, like a cloud ops engineer does not do that. They're not one engineer. They're three short engineers wearing a trench coat, passing themselves off as a cloud operations engineer. Credit to our SDM Josh Sulkers on the picture there. And then we see we're really, yeah.
Yeah, we talked a lot about this, and it was like, how do you describe it? And really one of the things is that the ops engineer, it's that is the core. They have that innate curiosity to continue to learn new things, and that's why they're branching out into all of those areas. It's a necessity as far as to be able to go through and do these things. They take risks sometimes, not with production environments, but they're taking risks to actually learn new things, try different ways of working, automating things. They're starting to get much more into kind of that transformational role with engineers.
Yeah, and there's two sides to taking risks there. I mean, there's the side of taking risks where you're actually going to put something in danger, and we are obviously averse to that. But there's also the side of taking risks that says you should be ambitious. The timelines that you set on your first disaster recovery scenario were unreasonable. You knew you weren't going to make them. But we took that as a goal anyways, because we wanted to say, look, even though we're going to succeed in something that the business may consider acceptable, we don't consider that acceptable. We know that we can get above a much higher bar than this, so let's set a bar that's going to be hard. And so we don't try to tell people like, all right, go and set a reasonable goal that you can meet easily. No, set an unreasonable goal, and let's just make sure that we're all okay with missing the goal. When we miss that goal, we're going to have some questions about why, and we're going to have learnings about it so that next time we come through, we're not going to miss the goal. But we're not going to shy away from the hard problems just because we think that our failure rates are going to go up.
Absolutely. So this is kind of like another marketing slide for here, but it's really about how it all comes together from a customer enablement standpoint. So our focus was talking about operations, but you need all of those parts. So whether you're leveraging professional services or where we're from, AWS managed services, or training and certification, all of these pieces and support come together to help enable you to be able to do the same type of things that we're doing, or to have those conversations with us to figure out how you can optimize your operations further. There's a couple of other related sessions that are coming through that you might want to take a look at as well that have a little bit more of an operational focus. One of the things we were noticing as we were going through, ops is light in some of the sessions, so we're kind of lobbying to get more ops sessions in here, because I think that's where the key is. That's where a lot of enterprises are going to start getting that
and to shamelessly plug this, we'll ask you to make reviews at the end. That's how we get more sessions on operations. So if you want to see more operations content, let us know through the feedback system. That's actually how we decide what we're going to show next year.
Absolutely. And so, you're spending a whole week here at reInvent. There's a ton of sessions that you can actually go through and you can learn. Please don't have it actually stop here, however. Like, go back. There's a ton of things offered by our training and certification organization for enterprises, whether that's online learning, in-class learning, blog posts. Just get out there and actually take advantage of what's there. There's more of these things. We actually put things out as well to show kind of what we're doing, and as we learn, we're trying to push that out as well. Thank you very much again for coming today, especially rainy day and during lunch. What more can you ask for? We really do appreciate you guys spending the time with us. And as Orion alluded to, could you please actually fill out the survey at the end? That is what helps us make sure we actually curate content to what resonates with the most people that are actually in here.
And let us know what specific things you want us to go into further, because we can cover a survey of topics like this, but obviously we'd like to spend a full hour on each one of these. Let us know if some of them resonate with you, that you'd like us to go really deep in some of them. If there's some aspects of operations that we're not covering that you want us to really dive on. This content is based on what people told us about last year. So just let us know. If you want to see more operations content, give us ratings. That's how we do it.
Absolutely. Thank you again.